G'day guys. I don't know if I want to talk about Minelab in this one, but I've got some other interesting things. Oh, look at my hair, my God. I went outside. David just dropped around. He's swapping the tyres or wheels around on his car for even wear. And he's off to Hoppers Crossing to go and see Adam to give him his modified 6,000 back. So Adam, if you see this before David gets there, you won't, because I think you'll be there in about an hour, and maybe I'm stuck on this for an hour, so it might work out about the same. And yeah, I've got some interesting ideas for other detectors, and I can show you something, a bit of what we have been working on. I can't show a lot because it is, well, we'll just say it's commercially sensitive, but I can show you bits that do not have code and stuff like that, but I can give you an overview of the power of it. And here we go. And I'll show you what else is out there that I've been checking out, a few things that you can get, and you can use them as a building block to make a detector or an absolute awesome pinpointer. I've got messages popping up everywhere. I've got the iPad here. I just sort of on the fly. David's not answering messages. Yeah, okay. Michael, we'll just say the name is Michael, not last names. Hi mate, could I get a price on upgrading my 5,000? Thanks. P.S. Just finished watching your chat about Minelab. Yeah. Possibly closing down third party, etc. Interesting conversation. Yeah, okay. I won't answer you just yet because I'll get sidetracked. But yeah, I got your message. How's that? See, this is what happens. It's just peppered with messages. Anyway, I was going to show you this thing I found on eBay. It might be a good little starting point project, and I'll go through it and explain it, and I'll show you how easy it is. But you could do your own. But this is relatively cheap, and it's a PI. It's a pulse induction. So this would work great at the beach. It would, it's not going to make a ripper detector as such, but you could modify it to be a really good detector. Let's have a look at it anyway. I'll spin that around. I'll move this over so you can see it properly. But this one's really interesting. I hope the audio doesn't die, because someone said that if the microphone is offset, it gets weak. So anyway, I found this on eBay, and the handle here lines up directly with the mouse. Hang on, I'm going to move that, undo that. Hopefully that goes up in the air. Oh, there we go. Otherwise, I won't be able to poke around the screen. There we go. You might have to zoom in on this. But anyway, what this thing is, it's called an Impulse M. And it's made in Kazakhstan. I'm not joking, right? But I'll just get out of that part of it for a second. US $31.90 or $50 Aussie, and 10 bucks or $17 Australian for postage. But yeah, it is located in Karaganda, Kazakhstan. So what's he call himself? Oh, to the MAALEXEY. Anyway, it's under metal detector kit, with kit in large letters. But I had a look at this thing. We'll make it big again. And it's got all the basic building blocks. Oh, dear me. Look, Google's onto me. They're going, oh, no, you're not going to show that. Come on. Oh, that's stupid. Okay, let's do it now. I'll do that like that. No. Hey, how's that? Doesn't want to work. How about if I click that and click that? Go big. That's very strange, isn't it? I had big pictures before. What's going on? Anyway, the more interesting part of this is this part here of the circuit board. So I'm going to go over that. If it gets, make it big. Okay. Okay, here comes all the more messages. But hang on a sec. Maybe I've got to shrink it down a bit or something. Maybe it's just too large on the screen. Hang on. Refresh the whole thing. There it is. Oh, that's a bit better. Okay, this is what it is anyway. You can probably see enough of that, hopefully. It's got a couple of buttons on it. But let's go over the main part of it. We'll go over the screen. There's your screen. It's got a bar graph on it. It does have speaker connection, and obviously it has possibly a variable frequency, or is it an indicator? I don't know. I don't own this. I just looked at the circuit and I thought this would be very, very easy. Oh, there we go. Let's go up here. Now, this whole thing is controlled by a PIC, a 16F 132, is it? I don't know. It doesn't sound familiar, but I used to use the 877s. But whatever it is there, it's pretty hard to see. But obviously, it'll come with a PIC chip pre-coded, and it will definitely have the fuses burnt that you can't read the code out. That's standard practice. I did have something roll up once that didn't have that done to it, but it didn't go out the door. But if we have a look at this thing, right, basically it's very, very simple. So this is your main controller. That controls your timings. A PIC chip like this to control a detector like this, I could actually write the code out in the back of a notepad in probably about 15 minutes. It's not hard as long as you have your initial timings, and it depends how complicated you want to make it. But something like this, if you just want to make a detector for beach, underwater, this is a good building block. And if you have a look at it, right, what have we got? There you go. It's got an 8 meg crystal or 8 megahertz resonator, depending what it is. I know it's black. Two capacitors to it. Still could be a resonator or a crystal. If it was a resonator, I would put a crystal in there. And you can even use a 4 meg crystal, which is a dime a dozen, and just operate it at double frequency. It's easy enough to do that as well, just by a little bit of fudging with the capacitors. But anyway, neither here nor there. So yeah, just surface mount resistors, a transistor of some sort. We'll find out what that is in a minute. Okay, it's got an LM339. It's sort of had the numbers rubbed off a bit. That's a comparator. Over here we've got a TLO72, which is I'm pretty sure from memory it's a dual op amp, like a CMOS input type op amp. Not that it's really that important, but you know, it does help with loading the previous stage if it's a CMOS one. That is a, I think, how have they got that configured? That should transmit FET there. It's all backwards, isn't it, or something? It's funny. What's that? Or is it a Russian? No, it's ST. So it's ST. I'm reading it upside down. Okay, ST6N056, I think, is it? Or 1056, anyway, 6N. So it could be, I don't know, go look at the volt. 600 volt rated device. Doesn't have to be that high. If you want to put a stack of Zenas across the flyback or something, you can knock it down, but it may even have provision for that. I haven't looked that much into this. So what's that there? Oh no, sorry, it's not. That could be a, I'm just having a look where it is. I need to look at the part number. That's what I need to do, but it looks like another MOSFET. Maybe it's part of the no, it can't be. Or it might be. No. Like I say, I haven't got a schematic for it. But anyway, this is a good building block. You just crow it out in oscilloscope. You work out what's what very quickly. And yeah, where it is, I can't see where the track work goes and that, so I'm just guessing. If I went further down here, I would have said, oh, there's the output stage. An IRF 740S, not a 5. But where these designs, which I don't like and which Minelab's own designs overcome, is this here. Well, the way they got it set up here, I'm just trying to look at the tracks and just make sure I'm on the right one. But that one being so damn big, this is part of the damping circuit for the flyback, and they're doing the old trick here with two diodes that basically squashes the flyback, burns it up through the resistor, and when it falls below the conduction voltage of the diodes, 0.6, 0.7 of a volt, that runs off into the op amp and then gets sampled. The op amp is probably always on, and this chip up here, the PIC, says basically turn on our little window, however they're going to do it. Might be transistor, I don't know how they're doing it. Might be even just yeah, might be something of this device here. I'm just looking at how they do it. Usually someone just use a JFET, but I can't spot one. Maybe there is, maybe something on the back of the board, but no, I'm looking at the other picture, probably not. But anyway, this will be a working pulse induction detector. But the thing is, it's very basic. And if we go here, do that picture, well, the whole thing runs on about 4 volts, which is okay. But what you could do with that, you could put a regulator in circuit for all the electronics and run another couple of cells for separate transmit drive, bump it up to 8 volts or something of that nature. It will work, just might have to increase the size of those 2 little glass diodes, because you're going to have more box lightning coming down. But I'd clip the flyback with some high power Zenas just to drop it down to a more manageable voltage. Well, in most of the detectors out there, they limit it to 120 to about 200 volts. So stack of Zener diodes of that nature, and just run 2 supplies. Just find out where the transmit FET gets its power from. Make sure there's nothing else going to it, which you're going to take out of circuit, but then put higher voltage on it, and you'll get a more punchy unit. I don't know what this is here, if it says it comes with the coil. Maybe it does, maybe it doesn't. Maybe you get a former. We should have a read. So anyway, it's cheap for a building block, and you've got an LCD display. Go and buy an LCD display by itself. I mean, price-wise, it's all right. Now we'll go down here and just see what it says. Pulse induction metal detector, Impulse M. I would say that the PIC code on this is probably used in just about all these generic cloney type things. You can probably find it on the net. You could probably find the code for that chip anywhere as open source. Go for it, and you can play around and put in different timings and all sorts, add timings, whatever you want to do. Let's have a look at what it says. It's a microprocessor based pulsed metal detector with automatic coil tuning. Automatic coil tuning. Aha, that's why it had that other resistor there, I would say. The metal detector has high sensitivity. No, that's debatable. It's able to work with coils of various sizes from 10 centimeters up to 2 meters in diameter. Wow. Using this board, you can assemble both a conventional soil pulse metal detector and a deep metal detector to search for large metal at a depth of up to 1 to 2 meters. Well, really depends on the size of the metal. And yeah, like I say, it's a building block. It's something to get your head around if you want to learn all about metal detectors. And the basic functionality of that, I mean, it's pretty basic within reason. And the code for that sort of stuff will be readily available. I bet you I can just go on there and find it right now. Just put the PIC chip number in there, code, metal detector, it'll come up with a project. It's probably, like I say, it's an open source thing. Someone's done it as a project and everyone's jumped on and made boards. Okay, so it's that simple. Yeah, supply voltage 9 to 16. 9 to 16, but obviously it's got a regulator on there for all the other stuff. Like, you're not going to go and put 9 to 16s into a PIC chip. It will let smoke out. But maybe the way it works, you can just check out the regulation of some of the power supply stuff, what connects to what, and maybe you can, if you want to, you can stick 16 volts in it. Maybe that does go to the transmitter. That would, yeah, make sure you heatsink the transmitter output MOSFET. It'll get hot. So what else we got here? You can adjust the volume level. You can adjust the threshold. It has a zeroing, so obviously it may have a bit of thermal wandering. And it's got smart noise reduction, which is probably just an impulse filter done through code in that PIC chip. So that is really, I would say, of all the little PI projects out there, price-wise, this is probably one of the better ones, considering all the little surface mount parts are supplied and they're all on the board. Try and do that yourself and you're there for ages. So he's got other items. It's got 100% positive feedback. Oh God, I'm giving him a plug, aren't I? And 363 items sold. I know. Look at his other items. I'm intrigued now. He sells Geiger tubes, low voltage ones, or low current ones, I should say, not low voltage, and an antique bronze knife, which he possibly found with his metal detector. But anyway, yeah. So there's your kit. Best offer AU $50, or best offer from Kazakhstan. So there you go. I think that's quite interesting. I bet you he sells a few now. Okay, I'll have to go back here. But have a look here. There's a few things popping up. If you want a plus and minus voltage 5-volt power supply, there's one there. Probably be as noisy as hell, but you put a single voltage in and you get plus and minus 5. So if you want to use op amps in a circuit that work plus and minus 5 volts, makes everything easy to do, actually, rather than going for a single rail. You don't have to do any voltage level translation for weirdo stuff. You can use something like that. $27, whatever. Mini Pulse Plus. That's a Pulse. Is it Pulse or not? Oh no. Have a look at that too. I think you only get the PCB. $18 Australian. Where's it come from? Oh, Coffs Harbour, New South Wales. $10 postage. So it's a beach detector. I'm just having a look at the overall design. I'm just having a bit of a look, see how they've done the configuration. Oh, it might. Let's read it. I don't want to look at a circuit diagram. Oh, it's not even a circuit diagram. It's just a board. Yeah, okay. Cheap to build, well documented. Build process, good depth. Can be adjusted for golden nugget hunting. Performs well in salt water and highly mineralized soils. The transmit oscillator can be adjusted by onboard trimmers. There you go. So it's obviously it's not microprocessor controlled. And there's your build instructions there. It goes to an open Dropbox account. So on there, it's got all the yeah. Oh, here we go. Another hammerhead. Revision D to E with insignificant alterations. So obviously, okay, it's yeah. Someone said that it's based on a hammerhead, which you can go read about on Geotech and find out all about that. What do we got here? Oh, this is this thing from Iran or somewhere. Oh, there's another one under here. Okay. Oh, they're coming up from. Oh my God, I've opened up Pandora's box on metal detector PCBs. There's a Tesoro there. That one's a Tesoro. Obviously, it looks like it's got a big long PIC chip in the middle. Metal detector IDX Pro surface mount version. You need to go and have a look at the schematics of these. A Delta Pulse, obviously pulse induction. I've seen these before, and these are an interesting one. I'm pretty sure it's that one there, is it? Let's have a look at this thing here. Look at this. Okay, that long PIC chip shows up again. Feles 00PI. I think these are the ones that were, here we go. This one's located in Bulgaria. US, $14, $22 for the circuit board. The dip version. So I haven't built one of these up. Hello, I sell brand new PCB for metal detector. Felesju PI. Pulse induction metal detector with discrimination. Works with double D probes, I mean coil, with a frame. I provide a parts list and saturation diagram. Instruction, not saturation. Please change that. Unless you want to dunk it in water. Oh my God, it keeps opening up. There's all these kits out there. Anyway, golden mask. So this is interesting, isn't it? They're all out there. I got these funny ones here as well. These things are coming out the Ukraine in various. That is that in a box. Yeah, but have a look. Anyway, we're getting off subject here. We're starting to go into oscilloscopes, but yeah, there's one with a coil and a box and a shaft, pulse induction metal detector, the Pirate. There you go. I think is the price on top? Hang on, I've got to click it to see if where they got the prices. No, $226 for a complete metal detector. Or maybe you just get that. I don't know. I don't know if you get the whole thing. Or maybe it is a kit. I don't know. Let's read it. Item description from seller. With two controls, roughly, precisely. Okay, whatever. Speaker, headphone jack, the coil wound with 0.56 millimeter enameled copper wire, not a twisted pair. Okay, well, you make a transmission line if you do that. It won't work, will it? Has no false positives. Really? It does not respond to branches. I hope not. The sensitivity control can be used to filter out small debris, such as what? Unexploded ordnance, or is he talking very small lead shot, bird shot that's all over the place? Anyway, they are available, and that's cheap. There you go. $11 postage US, 17 Australian, and you end up building that thing. But if you want to have a look at some serious metal detector stuff, I can't give you too much on this, but I'm going to show you anyway. Where am I? Okay, this is what we are building a detector with the base design, an NXP, basically an evaluation board. The only real bit of kit in there that we are interested in is that thing there. It is very, very fast and does a lot of stuff. Actually, we might even scrap this design and go to something better again. But you know, it is what it is. But I'll give you a little bit of a look-see at some of it, but I can't show you anything critical. I mean, this here, you can look at it and you won't know what you're looking at. But if you have a look at some of the stuff there, that is the actual MXRT 1064, and there's supply and a little bit of power supply stuff there. I mean, there is a lot on here, but you know, I can't go and show it all because, well, you know, you can look at the power supply stuff. I mean, it's neither here nor there, but you know, there's other stuff, you know, if you want to go, you know, well, you know, there you go. But I don't want to, oops, go away. But yeah, you can have a look at that. But you know, that will not be, well, you could base a circuit board and put a lot of daughter boards and connectors and peripherals on that board and make a really good detector. But like I say, yeah, you know, I know there's particular parties who don't like me saying we're making a detector, but we are, and it's going to be a damn good one. It'll be an absolute doozy. We actually did build one. We built one that worked quite well. It had a lot of functionality. It did a lot of stuff. I think it's in one of my very, very far back videos. And basically, it had all sorts of active earth field cancellation, all sorts of timing windows, tons of stuff on it. I don't want to go into that too much either because I'll probably, you know, give the game away. But yeah, we built this up, and it was going very, very well. Basically, with it had a lot more to it than just this. Believe me, that's just the processor part of it. With using a few peripherals on there, but there's some stuff there that doesn't cut the mustard. We had to use other stuff, and I've got more stuff coming at the moment. So yeah, that is what it's based on, NXP stuff. So yeah, we you look at everyone has a specialty of what they want to use. Yeah, I looked at building it up with some of the Renesas micros. I looked at ST, a lot of the ST stuff. You can actually more or less build one up. Like I already did build one up using Arduino and the STM32 board, the ST one. But you know, I don't want to put something out there that just doesn't whip the ass off everything else. So you know, it's got to be better than the best, and otherwise it won't go out there. Like there was some designs we did do. They were really, really fast and doing a lot of tricky smart stuff, but they would draw a lot of current. Everything just wanted to use a lot of energy just because of the fast switching rates. So rather than you know, pull things back, marginalize the design, we're actually going to go and upgrade. So it might not end up being based on NXP. It depends which company out there supports us the most too, with little things for evaluation. You know, if we don't get it, we don't evaluate it, we won't use it, and that might be millions of dollars of lost sales for you. So I'm just saying that if you want us to look at your you know, parts, well, it's very easy to look up my address and send it and say, here you go, please evaluate our products. Please take that into consideration in your design work. So if not, well, guess what? I'm not going to go and buy everyone's you know, evaluation stuff out there. You know, basically, in a lot of cases, if it doesn't come for free, I'm not using it. You know, like I've got these beautiful. Yeah, I'll turn around this way because you know I look at that all day. I got these programmable variable gain amplifiers. I've got a couple of these. I've got these at a substantial discount, so we could actually use programmable gain variable amplifiers in parts of the detector, and there's so much of the input stage of these detectors that is crucial for the performance. And I see so many designs out there that just use a 1K resistor and 2 damn diodes, and they think that is the way to do it. That is totally bizarre, really. You know, and I've heard statements, you know, well, why use a low noise Why? This is the best one I ever heard. This is a beauty, and this is from someone who should know better. Why use a low noise input amplifier stage when the terrestrial noise is so great anyway? Yeah, right. Okay, go with that. No, sorry. Go and use your 1K resistor and your two diodes for the rest of your life. We'll see how good you go. But there's better ways of doing it, even using, we want to get away from using MOSFETs. And, if I keep talking about it, I'll keep letting out little bits of golden sprinkles that everyone will probably get onto. But, particular MOSFETs, even small signal MOSFETs, are noisy. They have resistance. They have recombination noise. They have all sorts of popcorn noise as well. They have channel modulation. They have channel capacitance to the rest of the circuit. Nasties can go up the capacitor and couple in on the drain and source. You can even get intermodulation in the devices, and it can go into the detector and do intermods with other stuff, then come back up the gate line. There's all sorts of things, and you're talking nanovolt levels, and people just don't realize. They think that they're building, hi-fi equipment or something. It's nothing like it. Well, it is. Frequency-wise, you can look at it like that a little bit, but operational-wise, no. There's so much stuff done in detectors, even to this day, that I would just say it's dumb, right? Well, no, it's not dumb. It's probably a level of knowledge or something. There's stuff I don't know about. Of course I don't. I've always said I've never really dived into doing, actually I got a certificate of digital I did at the TAFE back in the 1980s. What was it? I can't remember what it was. Certificate of digital something or other. I don't know. Never bothered using it. Pulled out all the inverters and went direct connect on LEDs and upset the teacher. I think I did. And inverted the voltage. Something stupid like that. And but he thought it was quite novel. And I said, well, what are you using inverter chips for when the current's only 5 milliamps per leg? And the chip's capable of doing it. So whatever. I was just being a smart ass. But this sort of stuff is what you want to base your detector design on if you make a really good one. Don't go and don't base it on pick chips as Arduinos, unless you want something a little bit pedestrian. That okay. There's all sorts of messages coming through, but I really think that there's big scope for improvement, and I don't want to give heads up to manufacturers. They would already know about this stuff. They probably send it to the bean counters, and the bean counters in the office go, "Oh God, you can't use that. What are you talking about? The ADC is going to cost us, $50 each. Let's go and use one you can get for $8.50 or something." The performance goes right. This sort of stuff. I'm no holds barred on cost. No holds barred on cost. So it's going to get very, very complex. It's going to be very different. But yeah, we'll put a detector out. I mean, I don't have any expenses now. I can fund the project quite easy. So it's not as good as Minelab's head start when they got $8 million off the government for demining, developing a. I think my friend Bruce Bilson was involved in that. Good on you, Bruce. He was a politician. He was a small business minister for the federal government, and he has moved on to do bigger and better things. But I know Bruce quite well. But he actually was on the committee back then. So, yeah, I know a little bit about it. I'm trying to watch that. I saw a payment go through. It was quite big. I don't know if it's incoming or outgoing. I've got to check up on that. Yeah. So I better. What the hell was that? Sorry, but I really want to check this because I saw it was just our bank and wakey wakey. I've got to go do that. Hang on, I've got the iPad here. I can get straight in on see what came in. Oh, thank God for that. No, I thought it was 5 digits. It wasn't. It's it's David on his way to drop off Ian, not Ian, Adam's detector, um, and he's going all the way down past where Adam lives, and he's going down to a place called Hopper's Crossing, and I've given him an esky full of ice bricks. He's going to actually go to the RJ's Filipino shop down there, and they manufacture really good Filipino food, which keep the missus happy. And he's going to get a whole heap of Filipino stuff. So yeah, some of it's really good. If you ever go to a Filipino shop, get tocino. It's really good. It's very thinly cut meat. It tastes fantastic. It's marinated. Or if you want a spicy version, that's really good. Get a sisig and have it with rice. I don't know if it's a lot of mucking around to make it. I've had all this stuff over in the Philippines. I was running around like a Michelin interviewer, like I was eating everything everywhere, and it's so damn cheap as well. I'd go and absolutely pig out, and it cost $10. It's crazy. Street food over there, sarde skewers, stuff like that, chicken, beef, pork, mainly pork. So a couple of bucks, and you got lunch. It's amazing. It's so cheap. Yeah, I wish I was living over there permanently. So it's all good fun. But anyway, back onto detectors. So yeah, sidetracked again. Stay on point. So yeah, with all the stuff, yeah, you want to find out about the rest of the Minelab code and stuff, go read page 13 on Codan's annual report, which I think has just gone out. And I said thanks to Paul for pointing that to me. I'm going to go and read some other stuff on the stock market, because I do invest in the stock market quite a lot. Right, so yeah, I invest in a lot of things actually, but yeah, so I thought that might be time to plough some money back into a really decent metal detector project. If it costs what it costs, that's what it costs. It's a business, development, and manufacturing, and anything to turn a dollar can be construed as a tax deduction or a income offset for a business. So sometimes, rather than paying a whopping load of tax within reason, if you need to run a project that is even a developmental, you can even get tax incentive write-offs through R&D programs through the government if you want to go there and jump all the hurdles and hoops. I'm actually having a fight with the state government at the moment. I should save it for another video. It's to do with when we all got flooded, and if your business was impacted, they wanted to give you a grant, and the grants were $5,000 was a grant you can get, and you could even take the grant up to about $50,000. So basically, I'll just a quick overview, just so Victorians know what our government's like. We'll call they say yeah, no worries, here's your grant, right? And then 2 years later, oh, we did an audit, you don't qualify. And I went, what, you fucking Indian giving so and so's? So yeah, they said I packaged it up and sent it to the minister, and yeah, oh well, we'll see what happens, because eventually the outcome, if it's positive, well then no one will hear anything about it, and if it's negative and they carry on like pork chops, well, guess what? They'll get their own free video, won't they? They'll get their own video over it on YouTube. So yeah, bad luck. I don't think the state government, even though they're probably broke, want bad publicity at the moment. So to all my Liberal Party friends out there, yeah, you can jump on the bandwagon and we can tell everyone they're Indian givers. Because what it was, I'll tell you what it is. They said, oh, no, you had to replace stock, da 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 da. And I said, yeah, it did. Got water damage in the garage. It was all in there. Even I lost a spectrum analyzer, which is worth more than $5,000. I sent them all the pictures of the stuff. And now they're saying, oh, but you only sent us pro forma invoices. Have you ever dealt with the Chinese? That's all they do. They don't give you another piece of paper. You go and do an international bank transfer on the pro forma invoice, and then the stuff comes. There's only a delivery docket. So, and they're going, oh no, you freaking got no idea about the real world, how it works. Bureaucrats, bureaucrats, I call them. They're like Democrats. Sorry, I know some of you don't vote for Trump over there in the US, but some of their stuff they've done is unbelievable. But yeah, we'll just ignore that. I hate bureaucracy. It's an absolute pig of a thing. Oh, and Nigel sent me this thing too about this bizzo about turning all our state parks into national parks, which will screw all the prospectors up big time. And I've got the gist of where that's come from. I'm going to do more research on that, and I'm going to probably do a video outing that as well and how that has come to be. It's something very, let's call it, we'll call it something very weffy or something of that nature. Something where overseas bodies want to govern your country, and we will give them the. I'll put my hand out of screen, but I'll give them the. Yeah, that sort of business. I'll give them the wrist. There you go. But yeah, it really. It really pees me off, no end. So yeah, I'm I'm getting geared up on this stuff, aren't I? Oh dear. So anyway, that's that. Thought it was just a bit of a hodgepodge, but it should be an interesting video. Keeps people in the loop of what's going on. So like I said, you want to find out about Codan, Minelab, go read the report. It's all there. Have a look at the profitability. Have a look at the numbers over the years. Have a look when they made peak profits. Have a look at the profits going down and then coming back a little bit and going up. And obviously they see a trend, and the trend needs to have an amend, right? So that's probably why they're going to, like people said, they're going to, in the report, go read it. It mentions Amazon and storefronts. So their words, not mine. Go read it all. So there was something to it. People said this, that, and the other. There's all these, the chatter going on. And the chatter has turned out to be somewhat true. So I don't know the whole ins and outs, but we'll see what happens. And maybe that's the reason you can't get spare parts, because they won't have any dealers that have techs in there or something. I don't know. Speculation. I don't know. But, we can always go to Anaconda and say, can I buy a wigwam for a goose's bridle for my detector? And they'll look at you sideways and go, fucking crazy. I don't know how it's going to work. I just don't know. But yeah, people have already said that too. They like talking to people who are in the know on the subject. And, I've been in Anaconda before, and I wouldn't ask anybody in there anything about a metal detector, because they're going to just give you the salesman spiel, which, is probably, figment of their own imagination and not based in any truth, because they've never used a detector. So, that's a bad point, isn't it? So apart from that, well, looks like we've got a little bit of a fight on our hands now with this national park thing. So I hope the PMAV or all the groups around Australia are in on the know of that and don't just dawdle about and let things just cruise through, and then we lose all our detecting ground, because it could be across the whole damn country, but that would impinge on a whole heap of probably, it could be somewhere between 200, no, it'd be more than that. Sorry, it would impinge on about maybe up to 500,000 people here that do some type of prospecting, be it panning, be it detecting, be it hunting sapphires, or any sort of recreational activities, four-wheel drivers, the poor union people, the workers who've gone and bought their Ford Rangers to go four-wheel driving. Oh, you wasted your money. You won't be able to go using it in the state parks. There's going to be national parks. It's all going to get cut out. It's going to get ripped out from under everybody. A national park, what is it? Oh, it's just there. It just burns in a bushfire every so often because no one ever goes there, and all the access tracks have trees falling across them and bollards and rocks. We live in stupid land and stupid times. We really do. Save the place no one can go to. We just know it's there, but it doesn't do anything. It does make a little bit of CO2 to oxygen conversion, but it would do that anyway. Crazy. So yeah, it's time to stand up to our draconian government and the draconian bureaucrats and advertise it. Put them on social media and just give them an ear bashing, because they bloody well need it. They're a means to themselves. They need to be outed for stupid decisions. Okay, they need to be outed. And I don't care if every prospector sets up a YouTube channel and broadcasts it. It'd be fantastic, because the more eyes and more ears, the better for the cause of protecting our interests. Anyway, enough of that. Have a good day. I'm going to go contact David and tell him to get whatever at the RJ's. Anyway, catches.